Thank you for joining us for the IEEE Computer Society Standards webinar series, brought to you by the Standards Activities Board. With over 225 standards that transform the way we live, work, and communicate, the IEEE Computer Society sets the standard for design automation, simulation, testing technologies, Ethernet and Wi-Fi, quality assurance processes, systems architecture, DevOps, and more. Standards deliver best practice processes for developing market-ready interoperating systems, products, and services. You can have an impact by joining one of the over 200 IEEE Computer Society Standards working groups. Participating in one of the working groups grants you access to information that reduces risks, increases proficiency, and shapes the future of the industry. Help determine what's next in computing technology. Learn more about our standard working groups at computer.org/standards.
Okay, so hello everyone. Thank you for joining us today and welcome to today's webinars from our Standard Activities Board series. And today's presentations from one of the IEEE Computer Society's newest standards, trusted data sharing, system architecture, applications, and new challenges. My name is Edward Au, and I am the chair of the Standard Activities Board Standard Committees at the IEEE Computer Society. Before we get started, I would like to address some housekeeping items. This webinar is being recorded. You can ask any questions in the Q&A box you see on your screen. Dr. Shah will answer as many questions as possible following the presentation. If possible, please reference the slide your question refers to. A copy of the slides and the recorded webinar will be emailed to you tomorrow. The IEEE Computer Society is a global community where you can learn about standards, management tools, and new infrastructures like the Trusted Data Matrix. Get involved by keeping up our ongoing calls for participation within standard board activities and connect with other professionals. As a part of this network, you have the opportunity to address the growing needs of standardization within many different industries and technologies. You can also expand your knowledge within the Computer Society Digital Library, which features almost 270,000 papers and articles highlighting the latest research in data sharing. Furthermore, you can go with other professionals through many different kinds of opportunities, such as technical communities, conference, local chapters. Information will be also shared after the webinar, and you can always learn more at our official website, computer.org. Circling back to today's presentation, the trusted sharing of data is the foundation of a digital economy, which has the potential to deliver tremendous benefits to digital transformation in many vertical segments. Based on consensus requirements, standards, and management tools, the Trusted Data Matrix is a data and resources sharing digital infrastructure to facilitate trusted, secure, and transparent and accountable data sharing, exchanging, circulation, and trading among different stakeholders. In this webinar, you will know more about how the challenge of industry applying the data sharing and trading are adjusted. You will also know more about the current related standardization activity in our society and in IEEE Standard Association. As mentioned, joining us today is Dr. Shah Wei. Dr. Wei is the Deputy Chief Engineer of Informatization and Industrialization Integration Research Institute of the China Academy of Information and Communications Technology. She is dedicated to standardization and strategy analysis of smart manufacturing, digital chain, trusted data sharing, and artificial intelligence. Dr. Wei is very active in IEEE Standard Associations and other organizations, including the ISO. Particularly in IEEE Standard Associations, she is serving as a member of the Standard Association Standard Board and various subcommittees. She is also the founding chair of the IEEE Computer Society's Smart Manufacturing Standards Committee and the funding working group chair of the IEEE P3158, the Trusted Data Matrix. And with that, Dr. Wei, thank you for being here, and I would like to hand it forward to you for your presentation. Dr. Wei, please.
Thank you. Thank you so much for introduction and opening, Edward. So, good morning, good afternoon, and good evening to everyone. This is Xiaowei, and thank you for Edward. Brief introduction on me. I'm the chair of IEEE Computer Society's Smart Manufacturing Standards Committee, as well as the chair of IEEE P3158, which is Trusted Data Matrix. And I'm employed and affiliated with China Academy of Information and Communication Technology as introduced, and I'm also an adjunct professor of Xi'an University. So today I'm gonna share our latest progress on trusted data sharing from the perspectives of system architecture, applications, and also new challenges. It's a very exciting work, in fact, which addresses the bottleneck of data sharing that we are facing. So now let's explore it together. And let me move on. Okay, so this is not, okay. Okay, wonderful. So the main content of my webinar will start from why, or what we call motivations. Then I will introduce what is trusted data matrix, which is the infrastructure of data sharing. In addition, I will illustrate the progress of IEEE P3158, the result of our use case study, the business viewpoints, and some contributions on functional viewpoints, process viewpoint, and also technology viewpoints. And last, I will share our future works and also the expected ecosystem of trusted data metrics. So in manufacturing, there are quite different types of data along the product lifecycle. For example, in discrete manufacturing, the CAD figure is generated in the design phase. Such a CAD figure could be provided by a design institute, which is independent with the factory, and it could also be provided by a third-party designer. So if the factory needs the CAD figure for manufacturing the product, say a fridge or an automobile, the CAD figure should be shared with proper protection between the factory and the design institute or the third-party designer. In some extreme cases, as we investigated, the 3D printing figures is kept in a very specific hard disk, which is escorted by a specialist from the designing institute in city A and to the factory located in city B. So this is what we are facing right now. But this is just an example of a single phase. These different types of data, as described in this picture, is always shared between or among different phases. For example, the production department needs the data from the supply chain partners and also the logistics service partner to make a so-called optimal scheduling that the raw materials arrive on time, while the final product could be delivered to the customer right after it is taken off the production line. And the sales manager probably needs to know the inventory as well as the latest trend of customers. And currently, with the applications of digital twins and digital thread, the history and real-time data of a target entity could be shared along the whole lifecycle and make prediction for the future failure. But from the above examples, we could see that the data is shared inside the enterprise or with ecosystem partners. Given proper protection of your data, will you consider share the data with completely strangers and gain some additional benefits except from selling a product? And if the data could be shared with any other person or organization in the whole society, it could ultimately solve the problem of data silo and the promising global optimization of the transportation, medical care resources, and etc. could be realized. Currently, the most common methods for data sharing, including using flash disk, writing an email, using fax, or cloud services. However, these methods suffer from low efficiency, security problem, and once your data being shared with the other person, you kind of lost the data sovereignty. It means that you could not prevent your data from sharing with unexpected person or organization, and you could not control the way how the data be used. In some cases, the business or technology know-how could be dug out based on the data that they're using. And these problems happen due to the specific properties of data. Different from other production factors like land, manpower, capital, technology, data is immaterial, so it is always easy to be copied. Since the data supplier may not know how the data will be used at data consumer, it is hard to decide the price of the data comparing to other resources. While for the data consumer, it is difficult to determine the owner of the data after several rounds of circulation. Based on analysis of the data properties, we have done a series of surveys and connected the following concerns of the stakeholders with more than 200 questionnaires. For the data supplier, they worry about the losing of the data sovereignty, technical or business know-how being leaked, data being used out of the contract constraints, and when violation occurs, there is no evidence to prove it, as well as they address some regulation-related concerns. For data consumers, they worry about data quality because the data might be not match their requirements. And data interoperability is another problem if there exists multiple data sources. For example, if you connected data from multiple robotics or different kind of industrial software, then the interoperability is always a problem. And it's hard to trace back the data owner. And for some specific scenarios, data consumers might fail to find the suitable data suppliers if they want a very high quality or a very specific data asset. So there have been some solutions which could address part of these concerns as we investigate it. So these data sharing solutions include a big data platform, a data marketplace, or a data broker. They concentrate on the data sharing stage, especially the determination of the transaction pricing, as well as supply and demand docking. However, they cannot occupy the whole data lifecycle, from connection, transmission, storage, preprocessing, the sharing process, as well as the using. So in particular, the big data platform is usually built by government or trusted third party for data sharing. The pros for such platform is that it's easy for management and supervision, since it only needs to take care of the platform itself. While the cons also are raised because such centralized storage and control of the data may lead to monopoly on original data, cause the data privacy problem. And it's hard to keep the data sovereignty during the data usage stage because they don't provide such facilities. Due to the aforementioned drawbacks, as we investigated, so data suppliers are not willing to upload their original data to such platform. And for the second case, it's the data marketplace. It is also established by government or trusted third party as usually. Such marketplace could provide supply and demand docking, which is quite pros for it, as well as some third-party log record, and even clearing and audition by such provider. However, it is also not able to keep the data sovereignty during the data usage stage because after you bought the data from the data marketplace, there is no data usage control during the whole process of using it. And for data broker, they could provide intermediary agent services for data trading. It usually happens between the data broker and data supplier or a data consumer. So the data broker could provide some suggestions on the price according to their experiences. And the data price could also be determined by the market in some case. Since the data broker plays the role of an agent, it is hard to keep data privacy when the broker violates their code of ethics. And the efficiency is comparatively low, which is hard to apply in multiple data sharing scenarios. So in summary, none of these three solutions could provide an end-to-end trusted data sharing solution from the data connection to destruction. And you may see that after the data be shared with another party, the data usage control and discussion is even not discussed there. And they could not guarantee the data sovereignty during the data usage stage in this point. The risks caused by monopoly of data and data privacy problem hinder the willingness of data suppliers to share their data. To overcome these limitations, the trusted data matrix is proposed as a digital infrastructure to support data sharing. It is based on consensus-made requirements, agreements, and also several management tools, and provides control and management of data in its whole life cycle. With the integration of a group of software and hardware, for example, like smart contract and data usage control policies, authentications of the stakeholders and even the data, data catalog, trusted environment for data storage and transmission. With all groups of this kind of software and hardware, it could facilitate trusted, secure, transparent, and accountable data sharing, exchanging, circulation, and even training among different stakeholders. So during the discussion of IEEE 3158, we have further divided and refined the definition of trusted data matrix. So for the word trust, it is based on a trust root mechanism for both data and stakeholders, which requires the subject, which will be the stakeholder or the program they play, the object, which is the data or the copied data, or even the descendant of the data after several of the algorithm, and the actions of the subject should satisfy the agreed contract. So this is about the trust. While for the data, it is not a static concept. So it's not just the data asset itself. So in trusted data matrix, we consider the sharing of data asset and provide management and control during its whole life cycle. So it's more like a vertical, not just a concept. So while for matrix, this is somehow a very tricky term to be understood. We use this term matrix to express the scalability and extensibility from different perspectives at the very first point. So if we consider for the logic perspective, the trusted solution covers data asset and the terminal or the web server that's the data asset being processed, being stored and executed. And also, if there are a bunch of terminals cooperated with together, so it also includes the terminal ad hoc network establishing for a specific data sharing purpose. And for the space perspective, the trusted solution could support different scenarios, no matter it is inside the organization or from business to business, business to customer, or business to government. And for the solution perspective, the TDM is integrated with existing and future software and hardware. Just as I mentioned, there are a couple of software and hardware we are going to use. And we could always open the drawer of a function and replace the latest technology or solution inside this drawer to keep it as the latest and also the best integration solution at this moment. So in P3158, we try to analyze and establish the system architecture for trusted data matrix. And this is what we defined in the definition. We want to create a bunch of consensus-made agreements as well as the system architecture itself. And for this system architecture study, we want to include the business, functional, process, and also the technology requirements. And currently, we have 49 individual members from US, Australia, Japan, UK, and China. And all their working background varies from ICT, manufacturing, transportation, finance, medical care, and also energy industry. And in this standard, we follow the methodology of ISO IEC HV 42010, which is the architecture description standard to build our system architecture. And after the use case studies, we will spend every 2 months to work on each of the viewpoints. In the first round of use case study, we have connected 13 cases in different industries and divergent scenarios, among which we have made some statistics. So 59% of them are data sharing, between enterprises, and 83% of them transmit encrypted data to its partner. So kind of provide some secure protection for the data. And among 67% of the use cases happen to be peer-to-peer data sharing. So in this case, the data consumer proposes a request for a certain type of data. Then the data supplier will share the data in either encrypted way or not to the data consumer. In some of the cases, there is no record kept by the data supplier or data consumer. And in real work, this peer-to-peer model occurs when two colleagues in an organization want to share a file or other data. It could also be supply chain partners share their delivery time and vehicle information. In a more complicated circumstance, multiple data supplier tries to share their data with a group of data consumer via the help with an intermediary service provider. For example, in some large-scale companies, they have built data warehouse or centralized data platform to connect the data from different departments. After a certain process of data governance, the data will be provided to data consumer to optimize the production efficiency, improve the quality of the product, and so on and so forth. And the data supplier could also import their data into data sandbox. In particular, such sandbox is an area of storage where a few highly skilled users can import and manipulate large volumes of data. And the whole point is that these users frequently need data other than what's in the warehouse. As a rule, sandbox is only needed by a small user group, and it's only needed temporarily once the necessary knowledge is squeezed out and the data can be discarded. So there could also be multi-party computation. Multi-party computation is a cryptography tool that allows multiple parties to make calculations using their combined encrypted data and without revealing their individual and original data. So in this approach, the original data is kept in the data supplier, and they don't need to provide it directly to the data consumer. So only the encrypted data is used to make some calculations or is to generate some algorithms. And it's a similar case for federated learning. So for federated learning, it is used to train machine learning models from different data sets located probably in different sites, like some local data centers, a central server, or anything else. And we can do it without sharing the training data. So this allows personal data to remain in local sites, just like multi-party computation. And this will reduce the impossibility of personal data breaches. And in these scenarios, which we call it star network model, the protection of the original data has increased comparing to the peer-to-peer model. And especially in the multi-party computation, or in short MPC, or federated learning, we even don't need to access to the original data. However, we can tell from this star network model, the trust sharing mechanism of this approach is still not cover, the end-to-end approach, which is from the connection and to the destruction. And you may see that we have some protection layers at the terminal and also in the intermediary service provider. But what about the transmission links? As well as the actions or behaviors of the stakeholders, it still have some questions or doubts. And we also identify the main concerns of both data suppliers and data consumers, like we used to do, and I already shared that in the previous slides. And it seems that according to our use cases, the data sovereignty and technical know-how leakage are the most primary concerns for the data suppliers, while the data consumer take more care about data quality and interoperability. And these concerns will be one of the most important input for our design of trusted data metrics. And among the 13 use cases, several of them have already tried the third-party services. And this kind of services, including the identification and authentication of organization and personnel, data catalog, log recording, app store, supply and demand docking, auditing services, smart contract, and also clearing services. So through these third-party services, several data suppliers can exchange data amongst each other, thus can minimizing data transfers and leveraging services for data that guarantee the identity, description, services, characteristics, and also service controllability, among others. While different technology providers can create and offer a network of services with a common identity, common self-description, common controllability, and interoperability across their nodes. So this creates the necessary trust and also the quality of services and the critical mass to create value out of data and to deal with data gravity and also data distribution. So we also study the data lifecycle and data sharing lifecycle from the supplier and consumer's perspectives, respectively. And it is interesting to notice that only 15% of the use cases have destructed the data after using. So that is to say, only half of the use cases reach the closed loop of two life cycles. And since the majority of the scenarios are not data trading in the society range, so the third-party services like data source query or offer initiation and smart contract are not used frequently. And it's a pity that only 14% of the use cases includes data governance on the supplier side. And this may increase the risk of data interoperability in the later usage session. So remember that for one of the main concern from the data consumer is the data interoperability. Without such data governance, it's hard to realize that. And the experts also identify the main technologies they have used in their own use cases. So for the security technology, they have introduced encryption, say for identity authentication and sandbox, as we mentioned, container in the software level and also operational system levels are used. Multi-party computation, federated learning, differential privacy, and even homomorphic encryption are used to train algorithm without accessing the original data. And blockchain is used to keep log, and especially for the smart contract. The most important technology category is about the data control, including the access control, which is now commonly used, and also the usage control. And these are the very important technologies to keep the data sovereignty. This may also lead to the identification of the following 8 questions. Who is going to use the data? When does it happen? Through what kind of equipment? And from what networking access? Through which networking path? Which data asset will be used? And what actions will be executed on the data? And how to destruct the data at the end? So these 8 questions, in fact, should be covered during the usage control stage. And now let me share 2 specific stories for trusted data metrics. I want to thank you, the companies who provided these use cases, and it's really very interesting to see the applications here. So in the first one, it is about the logistics and the port multimodal transport use case. So here, a railway enterprise, shipping enterprise, and a logistics enterprise want to share their data with the port. And this data could be waybill, box truck, arrival time, route information, and also scheduling. So the port needs real-time acquisition of external data, and this external data will be used together with its internal data to carry out joint computing, and then provide assistant decision-making. In this use case, the data sovereignty is guaranteed through the limitation on usage duration of the data. Also, the port is not allowed to forward the connected data to other third party. So you can see that in this case, the data usage control has been executed, and the time of the data be used and also the range of the data usage have been taken care. For the next use cases, it's about multi-party computation, and the MPC is applied to train the quality inspection model. So in particular, the defective workpiece pictures will be first preprocessed in the local data source service to generate a computational factor. Then these computation factors from 13 different manufacturing companies will be fusioned into the MPC data center to generate the workpiece quality inspection machine learning model. The process will be carried on based on the MPC contract, and the usage, duration, and counting are executed by the control nodes. In this case, the trained quality inspection models has increased 30% of the precision comparing with the model that each factory trained by its own figures. So we can see that with such MPC, the manufacturing not only can work together despite their competitive status, they can also have a very good result on the model to help them improve the quality of their product. And the thing is based on the finding that the original figures are stored in the factory, no matter what. And this will omit the leakage of the technical know-how. And this is the most important concern from the data supplier. So based on the above analysis of the use cases, we have analyzed the first version of our business viewpoints, including an overall point of view and the data supplier viewpoint, data consumer viewpoint, as well as the third-party service provider viewpoint. So first, let's take a look at the activities of the data supplier, consumer, and third-party service provider as three black boxes. And let's pay attention to the colored arrows between each of them. So let's take a look at the blue arrows first. There are two blue arrows here, which transmit data or the computation factors generated from the data. So the first blue arrow, because you cannot see my mouse, which is the very first top arrow, and it is starting from the data supplier and ending at data consumer. It represents that the data is stored and shared in a distributed fashion. So we don't need to put the data in a centralized data lake provided by the third-party service provider or otherwise. While the second blue arrow represents the processing of computational factors for privacy computing. So multi-party computing as well as federated learning could use it. And the third-party service provider played the role of a centralized algorithm computing center. Such trained algorithm model will be then used by the data consumer. But in some cases, if the data consumer has a very sound computing infrastructure, such algorithm generating activity could also be located at data consumer side. And there are other information transmitted between third-party service provider and supplier or consumer. For example, metadata is used to generate data catalog, which will be queried by the data consumer. So in this case, we don't need to put the data in the centralized platform, but we need the metadata to describe what kind of data can be traded or shared in TDM. So that's why we need metadata to generate such data catalog. And we also need identity authentication to provide it to all the stakeholders, equipment that access to TDM, and even data which is inside the TDM. And the data apps are the packaged program which could be sold and used directly without training. And after the data being used, the clearing information and audition information will be shared among different stakeholders. So that's give us the colorful arrows in this overall point of view. And let's take a close look of the activities for the data supplier. So here, the data usage request is an input from the data consumer, while the smart contract is the input from the third-party service provider. And inside these books, after authentication, the data supplier will first upload the metadata to the centralized data catalog and wait for the request from the consumer. If the received data request is already satisfied, the data supplier can pre-process the data and prepare to transmit it to the consumer. In most of the cases, this pre-process includes data masking and encryption, and it will also be processed as computational factor in MPC or federated learning. While if the data request is not satisfied directly, which means that the data supplier doesn't have a data ready on its hand, so the data supplier probably need to connect and process the required data. Then the usage control strategy will be formulated based on the contract, which indicates the boundary conditions of using data and the possible violation actions and other agreed items. So all these activities happen in the data supplier will be kept in the log for future needs in audition and clearing stages. For this activity, especially for the data supplier view, so the output from the data supplier to the data consumer includes the pre-processed data, and in some cases also the agreed data usage control strategy, if they want to specialize that. And the output to the third-party service provider may include identification and log record. Let's move on to the data consumer viewpoint. So here the input from the data supplier may include pre-processed data and possibly some data usage control strategies, while the input from the third-party service provider may include like metadata from the catalog, contracting consulting service information, agreed smart contract, log record, and also some clearing information. Similar to the data supplier, after authentication, the data consumer may search the data catalog and try to find the right data supplier. Then they will move on to discuss the contract in details, especially work on the data usage control policies. So after the smart contract be agreed by both sides, the data consumer will receive and store the pre-processed data properly. It may be stored in a container, separated with their own data and program. When the data is used by any process or program, the data usage control mechanism will be activated to monitor the subject and its actions. When the boundary conditions is met or any violation occurs, the process or the program will be stopped and the data will be destructed. Then the clearing activity will be triggered after the data being destructed. The whole process is also recorded by the log. The output from such data consumer to the data supplier may be data usage status, and the output to the third-party service provider may include quite a number of that. So it may include metadata, catalog search demand, contract policy demand, log information, and also clearing service demand. While for the third-party service provider viewpoint, it provides identity authentication to all the stakeholders, equipment, and even data itself, and provides data catalog services, smart contract services, log record services, and also clearing services. I also want to mention at this point that in our discussion, some experts also want to differentiate the data owner from the data supplier. So here the data owner has the ownership of the data, while the data supplier may be a data agent. And some experts also argue that the data service provider could be also separated from the data consumer. So in their point of view, the data service provider used the data from data supplier to generate an algorithm, and they are not end user. But they will provide such generated algorithm to the real end user, which is the data consumer. So this will give us two more stakeholders. And some experts also consider to include a regulatory party in the viewpoint. This is especially important as they claimed in the clearing and also audition stages. And we will also have the further discussion on these points in our future meeting. So till the latest working group meeting, we haven't discussed and made consensus on the functional viewpoint. So here, for the incredibly of the report, I will also introduce the functional viewpoint from one of the contribution. So here you can see that the functional viewpoint is divided into 5 layers. From the bottom to the top is a data access layer, data transmission and management layer, the intermediary service layer, data control layer, and also the data application layer. And if we stay to the data supplier viewpoint, the functional view works from bottom to the middle, which is last 3 layers. So here, first, the data supplier will connect its data from the OT, IT, or other resources. and they will store and process the data for future use. They will also upload their metadata to the data catalog in the intermediary service layer for future use. While for the data consumer point of view, the functional viewpoints works from top to the middle, which is the top 3 layers. So after identity authentication, so the data consumer can search the data in the catalog, and they can sign contract with the data supplier. And the most important function lies in the data control layer. And this is to say what I have emphasized several times. When the data supplier is using the data usage control mechanism will be activated to monitor the subject and its actions. So it includes the actions for a specific person, organization, or action of a program. And it will also monitor not just the data itself. If the data being copied, and if the data has some generated descendants, it will also apply the same smart contract. So when the boundary conditions is met or any violation occurs, the whole process or program will be stopped, and then the data will be destructed. According to the activities analysis of the use cases and business viewpoints, we also have a first version of the process viewpoint, which includes first is a login. So as I introduced, it's like identity authentication. And we will generate the data catalog, and we'll also help the data consumer to search for the right data. And then there will be supplier and demand docking. So after such supply and demand services, they will sign in the grid smart contract with data control, usage control policies. And there goes to the data transmission and storage. I just want to emphasize that no matter it's at the end terminal or the web server or during the transmission, we need to very pay attention to the security problems that may cause there, because we always want to provide source channel joint protection for the data. And after that, after the data being properly stored, so we will apply the data usage control, and until the contract boundary condition meets, so the program will be ended and the data will be destructed. So that will trigger the final clearing services. And during the clearing services, they properly will check the log and also the data accounting information to get the right result of that. At last, I just want to share the latest version on technology viewpoints. So for the data control, it represents the control and management of the subject, which means the organization, personnel, and also the programs they are used to work on the data, as well as the actions, probably like read, write, or any other actions could be taken on the data, and also like I said, the copied data and also the generated data from the original one. So the data and will be taken control as well. So when an abnormal event occurs, corresponding actions will be executed. So normally this means that the program will be ended and data will be destructed. And for the encrypted data, we don't need to destruct it. We just disable the key. That will be enough to help us to destruct the data. So there are three kinds of technologies, although they somehow have some overlaps because they come in sequence. So access control is the most acknowledged technology. So they take care of the subject, the action, the object, and allow it to read, to write, or execute, and so on. And for extended access control, it takes care of preventing data from sharing with unexpected person. And the usage control may help us to take care of the time, the count limit, the program whitelist, the blacklist, and so on. So we can always define the different usage control policies based on the type of the data and also the scenario. So that means for different kinds of security or trust levels requirements, we don't need to apply all of this kind of usage control policies. We just do need to find the proper ones. And currently, we are also working on such items, which is to say what kind of optimal usage control policies should be taken for a specific type of data at a very specific scenario. So this is the first type of data technologies. The second one is about the data encryption and also for data computing. So in this way, they use cryptology and protocol to protect data privacy. So you can see that with such technologies, just like the MPC, the federated learning, and so on. So you don't need to transmit the original data to the data consumer to encase the leakage of the technical or the business know-how. And the data suppliers' privacy could be protected in this way. And just I mentioned in the previous slides, there are a couple of technologies in this category, like differential privacy, like federated learning, and secured multi-party computation, and so on. And just want to mention that according to some researcher, this kind of data computing methods is have a very good protection of the data, but suffering from the efficiency of the data sharing process. So there always could be a trade-off between what kind of trust measures we can provide and what kind of efficiency that we suffer from. And the third kind of technology is the identity and authentication part. This is a very old-fashioned one, and probably you guys are familiar with that. I just want to mention that except for the very traditional and very classical technologies that we listed here, for like two-factor authentication, identity authentication based on consortium chain or identity-based encryption. So in the near future, there should be kind of authentication chains, not just like consortium chains, but this kind of chain will link the enterprise, the personnel, the equipments, and the most important thing is the data assets together. So with such authentication of this kind of pair of the stuffs, we can have like an ultimate solution for this data sharing thing. So the last technology viewpoint I want to address is the trusted environment. So this means that no matter we store the data in data supplier or even the data consumer, and or when we transmit the data from one place to another, we want to guarantee that the data located inside a protected and confidential place. So in this way, there are three layers of protection for storage. So it could be a container in the software layer or a sandbox. And it could be happen in the operational system level, like a virtual machine that we have used in our computer. And also it could be hardware layer security process. So this may be the highest security separation for the data. So it requires like TE or other methods to realize that. And also, just like I mentioned, that trusted transmission is also very important. So different kind of security protocols, as well as the secure gateways, could be applied to trusted data metrics to realize that. And so for our future works in the next step, we are going to study and also verify the business viewpoints, just as I introduced, and also study our functional viewpoints, process viewpoints, as well as the technology viewpoints in sequence. And with our study here in P3158, we also look ahead and have this kind of vision for the future of trusted data metrics. And you can see here that we consider trusted data metrics as an infrastructure for data sharing among different stakeholders and provides trust, secure, and transparent services. So it may be directly connected to the company or its data lake, connected to an industrial internet platform, and connected with the data marketplace, warehouse, broker, just as the very beginning, I mentioned these are the common solutions for data sharing nowadays. And this kind of connections is not compulsory. It's more like a flexible and compatible way based on win-win prerequisites. So everybody will agree on a system architecture, and we will define the interface and so on. So in this case, no matter what kind of way that you are using now, it's always easy to access the infrastructure provided by Trusted Data Metrics, and especially it's an end-to-end approach. And for some specific industry, as we investigated, they maybe need to establish their own metrics on their own. So that's why we have some very little cloud in the middle of the trusted data metrics. So these are the visions that we have for the data for the future data sharing model. So we hope that you can always come along to work with us on that. So with such promising future, we hope to work with more experts from all over the world. If you are interested in this project, you could always reach out to me via my email as linked here. And our latest activity will later be posted in our website. So thank you very much for your listening. I'm ready to take some questions. Thank you.
Thank you, Dr. Wei, for sharing the information about the trusted data matrix and also the current standardization activity she is needing. Just want to let all of you a quick reminder, because I understand Sha already go through this night, but just for those who join late, for all the information Sha present today, it is her. I just want to make sure that this is her personal opinions rather than the formal position of IEEE or IEEE SA. So please be looked at, especially for those who joined the call late. And now we go back to the Q&A. Sha, I actually have a few questions received from audience already. They are actually maybe quite excited about the work you are doing for the P3158. One of the questions the audience asks is, he know that there are several challenges related to data sharing. One of them is about the trust between the consumers and business that would like to use their data, and I believe it's also covered in some of your use case. So the question from the audience is, for the standard you are developing, does this focus mainly on the business side that you want the business to improve the trust to engage in data sharing? Or is your standards focusing on improving the customer willingness to share the data, or actually cover both of them? Sha, can you provide some insight on that?
Thank you, Edward, and thank you for the expert for proposing this question. It's a very good question. In fact, in our project, we try to touch both of these two items. So one is to establish trust among business to engage in data sharing. So this is why we want to have this system architecture point of view, so we can have a common understanding of what kind of trust services we need to cover. Just as I mentioned in the webinar, it should not just protect the data itself, it should also take care of the stakeholders, even the equipment access to data sharing, and also the links that's used to transmit the data. And also, after we build such mechanism and understanding, we can ultimately improve the customer's willingness to share data. Because as we investigated in the questionnaire, why the data suppliers don't want to share their data lies into the loss of their data sovereignty, and also afraid that some of the technical know-how or the business know-how might be leaked with the data sharing. So with this such data usage control, after the data being shared with the data supplier, you can always take care of the data sovereignty. And since you have this contract, which already agreed and also signed about what kind of actions you allow the data supplier to do. For example, you don't allow they to share the copy of the data with the others, which is the extended control. or you don't like the data supplier to use your data to generate some certain type of algorithm and so on. So ultimately, with such data sovereignty addressed with the concern of the technology leakage being addressed, I think that we can improve the customer's willingness to share their data. So thank you for this question. Thank you, Edward.
Great, shot. So I think actually the second question that I have the expert to ask you, maybe you already partially answer in your first question. For this second question, actually, the audience is maybe asking the difference between the trust and data privacy, because she actually wants to ask, does your standard aim to develop a unified framework that can address the data privacy issue? So maybe this is a little bit challenging, especially I'm not sure about her definition of data privacy, because you also consider trust. But Sha, can you still provide some insight on that? I mean, rather your unified framework actually address anything on the trust or anything on the data privacy?
Thank you so much, Edward. Let me try to answer this question. In fact, I think that data privacy is also take care during this work, although we are not, concentrate just on data privacy. So in this case, we try to, in fact, build a unified framework for the complete process for data sharing. So just as we introduced, it's more like the data sharing lifecycle stuffs. So in this case, data privacy, especially like the personal privacy, could be addressed because it's one kind of data. But for trusted data metrics, it's in fact irrelevant to what kind of data that you are used to trade it or used to share. But this kind of privacy leakage stuffs is already considered. No matter it's within with the MPC or other methodology, probably this expert is very familiar with, or using the data usage control policies. And this is even applicable to like the figures, the CAD figures, as I introduced in the first slide, not just for the algorithms that we are generated for AI stuffs. Yeah. Thank you, Edward.
Okay, great. And I think there's a related additional question that I just received. An audience asked, how will the personal identifiable information be handled? Does your standard cover this?
I'm not sure what does the personally identifier information. What does it mean?
I am not sure also. So I think the audience is on the call. So if he or she can provide more information in the chat box, I can help him or her to follow up this question. Sure. So maybe let me ask another question first. Then there's another question. It say, what is the IEEE standard regarding the data destruction when data sharing contract ends? Will the key destruction enough on encrypted data? Why does the data consumer can keep an encrypted data without key? And what is the possibility that encrypted data be stolen and decrypted by, say, hackers? So I think the audience is asking about rather the key, I mean, how you handle the key, especially the encrypted data, and rather there's a even though you develop a framework, will there still chance that the encrypted data be stolen and decrypted by others?
This is a very good question. In fact, thank you, Edward. So the thing is that for the encrypted data, we don't need to, distract it as, the figures that we're talking about. We just need to disable the key of the encrypted data. So that's enough for the data consumer to not able to open that data again. And the thing for you to mention about, the stolen or the hackers or something, this is very important, just as I mentioned, for the trusted storage and trusted transmission. So we hope that as we defined in this project, the data will be first stored in a container which is separated from the data consumer's own data and program. And when it is used by a program, it could be get out for in another secure container and to process that. And all this kind of security, IT security, and also networking security mechanisms should be applied, especially for the data that has a very high security concerns. So just as I mentioned, so for different scenario and for different type of data, you may want to use different kinds of solutions in trusted data metrics. You don't need to, apply all of them because it may look as like an overreaction. But for some of them, just like you mentioned, in these very extreme cases, and this data has a very high security requirements, so we can always include all this kind of very mature technologies in IT security, networking security, data security stuffs to in case this kind of extreme case happens. Edward, thank you.
Okay, great. And Sha, I hope you don't mind. I know it's already past the hour, but yes, the one last question. Do you want to answer it? Okay. An audience asked from you as the chair point of view, what is the most important enabling technology of the trusted data matrix? And for this important technology, do you foresee that the corresponding solution can be implemented everywhere, like in a terminal, in an edge, and even in a cloud?
Thank you so much, Edward, and thank you for expert to bring up this question. In fact, there are quite a number of enabling technologies of trusted data metrics, and the most important ones is the category that I listed in the data control category. Because this is really the one that directly addresses the data sovereignty and also the technology linkage stuffs. And you know that it's even irrelevant to what kind of data type that you are using. And as we foresee for such solution, but I just want to emphasize that data control usage control cannot be used alone. Just as the last question I answered, it should be combined with the trusted storage and transmission and so many other stuffs to help to protect the data. But for such realization, it could be stored in a terminal, of course. It could be a web server, and also can be applied in edge computing stuff. And of course, it could be applied in the cloud. The thing that for the terminal part, which is the end terminal for the data supplier and the data consumer, they can always use such a thing. And for some of the intermediary services, like what I mentioned, authentication, some third-party log record and audition and clearing stuffs, it could also be implemented in a private cloud or a public cloud. So it depends on the terminals that you are talking about or the intermediary services that you are talking about. Thank you so much, Edward.
Great. Thank you very much for the insight. Especially, I understand actually your standards are still at the very beginning. But there are many important information you already shared with the group. And I do hope that for anyone who are interested in your standard, please feel free to contact Sha offline and then to consider joining and contributing to her working group. So now we are going to the last part of the webinar here. So thanks again for all the great questions that all of you have asked Sha, and we are sorry if we were not able to address all today. And before we wrap up, I just quickly want to note that our upcoming webinar schedule. The next two webinars from the Standard Activity Board webinar series will be from IEEE 802, which I believe most of you know is the standard used for Wi-Fi and Ethernet. The July 28th webinar will cover future networking technology and the emerging networking applications they are intended to serve in the next few years. And then the webinar on August 31 will talk about one of the largest developments and projects in IEEE 802.3 Ethernet working group. The Computer Society will also be putting on 2 additional webinars in the second half of July. On the 22nd, from our distinguished lecture series, will be a webinar on the emergency and development stages of informatics. And on July 26th, we will also have our Build Your Career series that talk about choosing a career path. A link to register for all of these webinars will be sent to you tomorrow through the email, which will include the links to the recording of today's presentation, as well as a copy of the presentation slides. And once again, I would like to thank all of you for attending the webinar today, and thanks so much to Dr. Xiao Wei for sharing her knowledge with us on the challenge of the trusted data matrix and the work that she is leading the P3158 to develop a high-quality market relevant standard. And thank you again, and have a great rest of all of your day. Thank you.
Thank you all.
And Sha, thanks again.
Thank you. Have a good day. Bye-bye.
Bye-bye.